airbag project. The problem for this project was to construct an airbag to minimize the force exerted during a collision, as well as allowing a car with a block on top to stop without the block falling over. Some of the physical requirements for this project were items were provided by a team. Team spends less than $10. Airbag doesn't extend 15 centimeters past the front of the cart, and airbag can be removed with no damage. The functional requirements for this project included the airbag minimizes the force on impact, cart stops on impact, wooden block doesn't fall over, cart starts at rest at the top of the ramp and rolls down the ramp, then strikes the force plate while the airbag remains attached.
Prototype number 1 is an airbag comprised of approximately a handful of cotton balls covered in 2 sheets of tissues into a triangular shape. This is a diagram of prototype number 1. Prototype photo is right here. Our hypothesis is that if the airbag is comprised of cotton balls in a conical structure, then when the cart is attached to the airbag and hits the force plate, the force will be less and the block on top of the cart will stay in place. The variables for prototype number 1 is size, shape, materials, and or density of the airbag. Dependent variables will be considered force exerted on the force plate after the collision and whether or not the block stays on top of the cart. Materials we used for prototype number 1 were cotton balls, tissue paper, and tape for the airbag itself. For the system, overall we used a cart, ramp, block, tape, force plate, computer with logger rope, and a phone with a camera to record the whole process. Video collision right here.
For prototype number 1, the procedure was to place the cart on top of the ramp with a block on top of it. The airbag should also be attached. Secondly, with the cart starting at rest, let go of the cart and let the cart travel down and strike the force plate. Thirdly, collect the data from the collision and create a force versus time graph, a velocity versus time graph, and an acceleration versus time graph using your data through Logger Pro. As you can see here was our qualitative data from each of the 3 trials. As you can see, force is minimized for each of these 3 trials using this particular airbag, but the block did not stay on top for any of these trials.
Here we have a velocity versus time graph for prototype number 1. We found that v is equal to negative 2.449t plus 2.908. We use this equation to eventually find the force in newtons, which is negative 1.347 newtons.
Here's our second prototype. A description is that it's an airbag with a cylindrical shape and it's made out of paper, and it contains cotton balls and held together with tape. Here's our diagram, and our photo is inserted here. For prototype 2, our hypothesis is that the airbag is comprised of cotton balls, paper, and tape in a cylindrical structure. Then, when the cart is attached to the airbag, when it hits the force plate, the force will be less, and the block on top of the cart will stay in place. Our independent variables are size, shape, material, and or density of the airbag. Our dependent variable is the force exerted on the force plate after the collision, and whether or not the block stays on top of the cart. And lastly, our materials are paper, tape, cotton balls for the airbag, and then for the system, a cart, a ramp, block, tape, force plate, computer with Logger Pro, and phone with camera.
For prototype number 2, the collision for the video is inserted here. For the procedure, place the cart on top of the ramp with the block on top of it. The airbag should be also attached. With the cart starting at rest, let go of the cart and let the cart travel down and strike the force plate. Collect data from the collision and create a force versus time graph, velocity versus time, and an acceleration versus time graph using your data through Logger Pro. For qualitative data, as you can see here, for each trial of the collision, the force was minimized for each one and the block stayed on top for each of the collisions.
Here we have a velocity versus time graph for prototype number 2. From this graph, we found that v is equal to negative 1.805t minus 0.4948. Using this equation, we found eventually that by using F equals ma, that the force is equal to 0.993 newtons.
So our explanation for our validation is that the airbag achieved its purpose because the force exerted on the plate was less than without the airbag, and the block stayed on top of the cart after the collision. So the explanation for verification is that all physical and functional requirements were met, included at the beginning of the video. And the issues with building, so we had trouble getting the tape to stick onto the airbag cart and the cart, and making sure that the airbag remained attached and before and after the collision. Some issues we encountered when testing was that the block kept falling off the cart and during the first prototype, and the force plate oftentimes did not record the collision. So changes we made and why we made them. So the first change that we included was using a cylindrical structure instead of a triangular structure. We also used a stickier tape to make sure that the airbag was more connected to the cart. We also added paper instead of tissue on the outside to create a crumple effect, and also extended the length and width to create a higher surface area to disperse the energy.
One improvement that can be made is using cardstock paper, since it's harder instead of the printer paper on the outside of the airbag to create more resistance and a larger crumple effect. This would help to accomplish both goals of the project. These are calculations. So in order to find the force, we took the slope of the velocity time graph, which is the acceleration, and multiplied it by the mass.